and welcome back to Microsoft Virtualization for VMware Professionals. This Jumpstart event is going to cover a variety of different Microsoft technologies and how they compare and contrast to our VMware technologies. I'm Simon Perryman, Microsoft Technical Evangelist and VCP, and I'm joined by Matt McSpirit, a Microsoft Technical Product Manager and also a VCP. Now, right now we're in our third module where we're going to be talking about security, multi-tenancy, and flexibility. Now, I'm going to turn it over to Matt. Why don't you go into a little more details of exactly what we're going to be covering here?
Yeah, so thanks, Simon. So in this first part, we want to look at how the security has really evolved within HyperV, and it links in with both network security, physical security, so how we can ensure that our assets are protected and how we can secure our resources on the network as well, and some of the work we've done in HyperV in 2012 to enable that. We'll then move on, because building on networking and multi-tenancy, how we can provide isolation and how we can deliver a rich multi-tenant infrastructure with the core features that are in Windows Server. And we'll touch on how that's enhanced with System Center, and we'll cover that obviously later in the afternoon. And then we'll wrap up with flexibility. You could term it agility as well. Ultimately, what it comes down to is how we can shift stuff around based on changing conditions. So, we need to live migrate VMs. Can we move storage? What are the shackles? Do we need clusters to do that? So we'll look at those kind of features as well. So there's loads to cover. Great stuff, a great section.
Great. Well, as we start on multi-tenancy, a lot of people say, hey, I'm not a hoster, right? Does this really apply to me? But a lot of these concepts are true if you're building one of these, highly dynamic virtualized environments. If you have multiple business units, multiple users of your VMs, sure, you're not a hoster to a third-party public people, but you're technically a hoster to your own enterprise, your own business units, your own individual users. So still being able to take advantage of this, isolate your networks, storage access, virtual machine control is going to be helpful to you as well.
Yeah, exactly. And to do that for organizations, even small organizations may have segments they want to keep isolated from one another. You might have a set of virtual machines that need to be isolated from another set of virtual machines for test or dev and production and so on. So there's loads of different things we can utilize in HyperV to help us do that. And we'll look at some of those across multi-tenancy and security and then flexibility. So first up, we'll look at multi-tenancy and security. One of the biggest improvements in Windows Server 2012 HyperV is this introduction of what we're calling the Extensible Switch. The name kind of gives it away of what it is. It's extensible. It allows things to plug in and be extended by partners and by customers directly. But what's the switch element? What are we talking about here? Well, we're talking specifically about networking. Now, in HyperV in 2008 R2, we provided a fairly simple, at least on the surface, network switch that would transform, and as you can see on the diagram here if I mouse over, it would transform the physical network adapter into a HyperV virtual switch, so ignore the extensible bit for a minute. It would transform it into a virtual switch that multiple virtual machines would then connect to with their VNICs, their virtual network adapters, and that would allow them to pass traffic out onto the physical network. So VM with virtual NICs, we can add multiple NICs, multiple virtual NICs per VM. They will connect to a HyperV switch that will be connected to a corresponding virtual network adapter, or physical network adapter, sorry. But what's changed? Well, what needed to change? Well, firstly, that simple switch that was in HyperV 2008 R2 wasn't extensible by partners. So partners who wanted to write monitoring software to plug in and help organizations get visibility into the packet flow and what's going on the network couldn't do it. Organizations who perhaps wanted to integrate from a filtering and a forwarding and an intrusion detection perspective, they couldn't go in at as granular a level as they wanted to. But with VMware, they had that opportunity in some cases. Some of the advanced features with the distributed switch unlock some of that. But the extensible switch changes the game for us because it enables not only a more granular set of configuration options that are in the box, but it also, as the name suggests, allows partners, customers, anybody who wants to programmatically deliver a plugin to do that, which is really powerful. Partners or customers, it's not just saying you've got a special requirement, you need to go and buy something to do it. If you've got a special requirement, you could write something to do it. And the beauty of this, and do you run HyperV on your laptop?
I do, client HyperV, yep.
So client HyperV, good. So client HyperV as part of Windows 8 has the same networking setup as Hyper-V in the server side. So I could develop on my local workstation running Windows 8 and Hyper-V that's enabled as part of that. I could build a switch extension there and then transport it over and move it over to the server side after it's been tested.
That's a great point. You know, I've actually seen a couple of questions about Hyper-V client, Windows 8 client Hyper-V, so just quickly want to address those. You know, first is just basically what features do I have, what don't I have, what's the difference? Basic way to think about this is client Hyper-V is restricted to run in local, meaning that you cannot connect multiple client Hyper-V servers together to take advantage of things like distributed switches across multiple laptops. You can't do clustering. You can't do live migration between two client Hyper-Vs. So essentially, it has the same feature set. You can build the same type of VMs, but you are really restricted to running it locally as a single individual unit. So use it for your dev, your testing, get that VM perfect, go ship it off, put it in the data center. Essentially, our goal here was to just better enable our developers to do their own building and testing locally before they go and deploy it in the enterprise.
Exactly. And that Hyper-V Extensible Switch, to go back to the networking element, you can integrate and plug into it in many different ways. But let's explore some of the core capabilities that exist as part of the virtualized network, the Extensible Switch. What it's aiming to provide is that deeper integration with existing network capabilities. Things like PVLANs. If you're familiar with VLANs, they enable me to segregate and isolate certain segments of the network. So I could have 10 VMs that are attached to VLAN 1, another 10 VMs that are attached to VLAN 2, and within the VLAN they can communicate, but any traffic between them won't pass because they're part of different VLANs. So it's a good way to segregate our environment. But some organizations need segregation even within the VLANs. And that's where PV or private VLANs come in, because they allow us a next level of granularity. So I could say, okay, within VLAN 1, where we've got all of these VMs, I could have PVLANs that allow us to isolate individual groups or individual VMs so they can or can't communicate. The Hyper-V Extensible Switch also provides a number of capabilities to protect organizations. Protection against ARP and neighbor discovery and poisoning, as you may have heard it referred to. So helping protect key workloads against that. Protecting against rogue DHCP servers on the network or rogue routers that may be out in the network. So we can ensure that they're protected from a Hyper-V perspective. We can ensure that traffic is ACLed at the virtual port level and even trunk multiple VLANs to an individual virtual NIC inside a virtual machine. So that could be handy if you've got a special configuration you're looking for, but don't want to give the VM lots and lots of network adapters. So we can help trunk their multiple VLANs to virtual machines. And finally, as I said before, we can help gain visibility into what's going on in that network switch. So from a monitoring, from a port mirroring perspective, these are all requests we were regularly getting from partners and customers around 2008 R2, and now we've delivered them in 2012. So I want to jump into a quick demonstration just to help organizations and you at home understand just how you enable some of these things. And as the bottom of the slide suggests there, PowerShell WMI management is key to some of these, to enable them, to tweak them, to configure them. Some of them will be exposed more through System Center, so you can do additional configuration there, but it's all can be configured there, either PowerShell or with System Center. So let's duck into a quick demonstration. I'm going to one of my machines here. There we go. So we're in Hyper-V Manager. I've just chosen I'll choose a random VM over here, Demo 8, and I'll go into the settings of this VM. Because what I can see inside the network adapter, and one common question we get, and you may have heard this as well, around the different types of network adapter in Hyper-V. With VMware, there's choices you can make. With Hyper-V, there's choices you can make as well. So if I go to the Add Hardware option here inside my demo environment, you'll see that actually I can add not just a regular network adapter, but I can also add what's known as a legacy network adapter. So there are two types here.
Now, when would you use one or the other? When would you use legacy as opposed to the state-of-the-art one?
How do you know it's state-of-the-art?
I assume.
There you go. So it is revolutionary. So the regular network adapter, the one that doesn't say legacy, is what's known as a synthetic device, i.e. it needs a driver. And that driver is core to Windows Server. So if I virtualize Windows Server 2012 on Hyper-V 2012, I don't need to install any extra tools or drivers for it to recognize that particular network adapter. On VMware, I would typically need to add VM tools to my VMs to optimize their performance, keyboard and mouse, all that kind of stuff. The network adapter that I've talked about, synthetic, doesn't need a driver. On older operating systems, so if I virtualized Windows Server 2003 SP2 on Windows Server 2012 Hyper-V or Hyper-V Server 2012, excuse me, then I would add the integration components, which is kind of analogous with VM tools.
VM tools, yeah.
So it's from a familiarity perspective, it's a little installer that I run to optimize performance, keyboard and mouse, the usual stuff. Legacy network adapter, to finally answer your question, when would you use one over the state-of-the-art one? Network adapter you should use as much as you can, but you typically boot it into the OS. Legacy network adapter is very useful if you want a Pixie boot, because it's a generic driver. I can't remember the exact card. It's like a really old virtualized Intel network card that nearly every OS under the planet, under the sun, has a driver for. So when you're Pixie booting a VM, and you want to connect it to a physical or a Windows deployment server or a System Center Pixie server, then the legacy adapter is going to have a driver that it can use at boot time to connect to the network. If you've just got the synthetic network adapter, it's not going to work. So that's available once you get into Windows. So anyway, back to the demo, the main demo. I just wanted to clear that up to make sure we're on the same page from a VMware and Microsoft perspective. This network adapter, you saw before, I can enable VLAN, I can enable bandwidth management. But if I expand, I've got some more of the advanced features here. So MAC address spoofing, DHCP guard, router advertisement guards to ensure that I'm protected against unauthorized virtual machines pretending to be routers or DHCP servers. I can use mirroring, so I can set this as a destination of which another virtual machine being the source would be able to mirror their traffic to, and therefore I could capture it, analyze it in the mirrored environment versus capturing it in the live, the usage environment that's going on. So they're just some of the features and capabilities. Many of them I could also enable through PowerShell, or I would enable through PowerShell. So you don't see any reference to PVLANs here. It's not something I could configure through PowerShell. You didn't see any reference to trunk mode to virtual machines, something I would do through PowerShell. All documented on TechNet, really easy. It's similar to that resource metering PowerShell script that I ran before. One line, 1 or 2 lines will set you up for that. Or you could automate it as well and unuse System Center. So back to my slides. So I wanted to build on this because Extensible Switch, it does certain things that we've talked about, but it also extends. And what kind of partners are doing extensions or providing extensions for the Extensible Switch? And trust me, partners have been waiting for this. They've been excited. They've been developing since we announced Windows Server 2012 at Build, which was, it seems like ages ago. What was it, September 2011? Was it?
11.
Yeah, so that was 2011, and yeah, released in 2012. So yeah, way, way back. And we announced even at the time partner support for the Hyper-V Extensible Switch. So Cisco with their Nexus 1000V. VMware admins who are using the higher-end editions of VMware's tools will be familiar with the Nexus 1000V. And Cisco are porting it over to Hyper-V, similar pricing and structure that comes along with the Nexus 1000V for VMware. But with Hyper-V, unlike VMware, it's in every edition. So I can use Hyper-V Server and apply the Cisco Nexus 1000V.
The free Hyper-V server.
Correct, yeah. I could use Windows Server Standard with Hyper-V and use the Nexus 1000V. I'm not required to go to a higher level SKU to then be able to use the Nexus 1000V in this case. They're integrating with their UCS VM Fabric Extender, so another component of the Cisco infrastructure that's more related to servers and storage, but it's integrating at that extensible switch level. 5.9 is an interesting one. Have you heard about 5.9?
I have. They were one of our OEMs that kind of adds additional components.
Yeah. So 5.9, they're doing some cool stuff around AV and agentless antivirus and virtual firewall. So this new extensibility we've built in opens up this switch so they can plug in their stuff, which means they can do it in a more optimized way, because they were doing it before slightly different, using a couple of extra components to effectively try and provide the kind of functionality we've now built into the extensible switch. So they can plug in, they provide things like agentless antivirus, so that's quite good for VDI environments. Quite handy if you're looking for low footprint agentless AV in that environment.
Now, while we're kind of on the topic of, installation on Hyper-V Core and configuration, I have seen a couple questions come up saying, what are my installation options for a driver on Hyper-V Core for an executable file? Can you just kind of touch on, the different mechanisms that people can go and actually add things to their Hyper-V servers?
Yeah, absolutely. So you could go old school and use PNP util. Nice. To add a driver. I mean, you're talking, it's getting technical there. But where I did for most of my my environment, the HyperV servers. A lot of the tools that you get, or a lot of the drivers that come from HP, Dell, IBM, the usual vendors, they come as an MSI or they come as an XE, and I just simply copied it onto the C drive of that device, that machine, and ran it. If you could, I'm sure you could set up remote installation. You could deliver it through Configuration Manager, or as part of, you could load drivers and utilities in as part of the deployment process if you're using, say, Microsoft Deployment Toolkit or Configuration Manager. So you can weave it in that way, or if you're applying it manually after, then I can just go in and run those XEs. They'll run fine. Broadcom utilities, HP utilities, the usual stuff.
Right, and of course you have a full scripting interface, so as long as you can programmatically access it, run it as an executable, you have that option too. Another question I had, in our older version of HyperV Server, so HyperV Server 2008 R2, we had a couple of third parties, such as Five9s, that provided kind of graphical user interfaces that you could add on top of the HyperV server to have these additional management options. How has that changed in 2012?
Good question. I believe that some of them still exist for 2012, so I do know the ones you mean. One of them was developed by a group within Microsoft that just gave you a bit more of the name completely.
Was it called Config?
It wasn't called, it was something like that, but I can't remember.
Okay.
Anyway, it was a little tool that gave you a bit more of a graphical interface. You could see the clock and change control panel.
There was some network settings you could configure.
It helped. It helped out a lot. SC config for the most part does more or less what I needed it to do. Some of these tools, I think Five9 was one. It wasn't a security manager product that relates to the Extensible Switch, but it was an interface that you could, and I don't know whether it supports 2012. You'd be able to go to five9.com and check that out, but yeah, I think some of them, I don't think there's a Microsoft produced one at this time.
So essentially, the message here is, if there's something that you're looking for to install on HyperV Server 2012, you're having trouble doing it in-box with scripting, with command line, there are a lot of vendors out there that are already supporting HyperV Server 2012. So just search online. You may be able to find a lot of these free utilities you could download and get that kind of additional graphical user interface that you're looking for.
Yeah, exactly. But going back to the Extensible Switch specifically, so Five9 would give you a virtual firewall and agentless antivirus capability that can really help organizations looking for that. Perhaps you've got a branch office, you want to put in a virtual firewall to start to segregate interaction between certain VMs in the environment. When we look at NEC, the first open flow product that's been released for Hyper-V, that's only been released in the last few days. So if you're using OpenFlow and you want to integrate with your Hyper-V components, the NEC solution is certainly something that's worth looking at. And finally, from a monitoring perspective, we're thinking about how we can monitor that traffic and visualize what's going on in that environment, how the packet flow is taking place. And Inmon, with their S-Flow product, again, plug in at that very granular level that allows you to collect and monitor and observe that information in a very granular way. So all of those extensible options, this is just 4. These are just 4 of the vendors with 5 technologies, the Nexus 1000V and UCS being separate ones from Cisco, across packet inspection, filtering, forwarding, and intrusion detection. So they're the 4 key areas that partners can plug in with standard APIs. So this differs quite a lot from the VMware approach, as we'll touch on later on. When we talk about that VMware comparison, the Extensible Switch on Hyper-V, compare it with the vSphere Hypervisor. So that Extensible Switch in Hyper-V, remember in all editions of Hyper-V, like we highlighted before, unlocks a lot of those other capabilities. PV-LAN, ARP spoofing, DHCP spoofing, port ACLs, trunk mode, and so on. Because we have that advanced networking switch in the core, we can enable all of those other subsequent features. With the vSphere Hypervisor on its own, and in fact, even in the editions like Essentials, Essentials Plus, Standard, and Enterprise, you don't have that option, because you need, on the VMware side, the distributed switch, which is higher end in the higher editions in the Enterprise Plus edition of vSphere, to unlock some of those capabilities. So PV-LAN, you're going to need the vSphere distributed switch. Trunk mode to VMs, port monitoring and mirroring, you're going to need that advanced SKU. But also, it's important to note that switch, that extensible switch on Hyper-V, where we've talked about how partners plug in, is a little bit different on VMware, because you would either use the VMware distributed switch to manage switches across lots of different servers, or you would use the Cisco alternative, or you could also use an IBM alternative. But it's one or the other or the other. It's nowhere near as extensible as what Hyper-V is providing in that extensible switch, so it's replaceable. But there's an important differentiator here. What I've talked about from an Extensible vSwitch perspective on Hyper-V is one switch on one host. What if I want to provide centralized management of all of my switches across all of my hosts and manage them as one logical entity? And that's where System Center later on will talk briefly about the logical switch, where that can aggregate the management of that. So when people are thinking distributed switch on VMware is managing vSwitches across lots of hosts, the logical switch provided by VMM on top of the extensible switch in each Hyper-V host provides that.
Great. Well, we have another great question that's come in here that I want to ask. So in VMware, there's this concept of having pools of VLANs where you can assign a particular VLAN to a particular VM. What do we have in Hyper-V that covers that? I could talk a little bit about that if you want.
Yeah, you go ahead. I need to mull on that for a while.
So built straight into Hyper-V since our previous releases, not just 2012, we have a broad set of VLAN capabilities where you can essentially pre-create VLANs, and then as you create your virtual machines, you can assign a particular VM to a particular VLAN. The way the interface operates within HyperV Manager is not quite the same where you have a pool of VLANs to choose from and you can pick this one or this one. You have to know the VLAN tag, the VLAN number, 1 through 64, I don't know, 1,000.
4,095.
Is it 4,095?
You weren't far off.
Okay, so you got a lot, one of those factors of 2 there. Now, when you get to Virtual Machine Manager, System Center 2012, we're going to talk again about that later. We have this concept of logical networks, where within a logical network, we do have some more of that granularity, where we can basically say, hey, I start with one big network, carve it up into lots of individual VLANs, and then when you're doing deployments, you have that ability to go and assign particular VLANs at that time. So we have essentially the same functionality built in, it's just presented in a slightly different way.
Yeah, that's a great way of explaining it as well. And when we think about some of the more advanced security features that we're offering in that extensible switch as well, the ARP spoofing, DHCP snooping protection, the port ACLs, and so on, you're going to need the VMware distributed switch on its own doesn't provide some of those capabilities. So you're going to need, in some cases, the app component of the vCloud Networking and Security product, so it's an extra SKU. So that gives you some more of the granularity and protection against certain attacks like the ARP spoofing, DHCP spoofing, or you could use the Cisco Nexus 1000V as well. So there's lots of different options, but where it indicates in the table VCNS, vCloud Networking and Security, it's an extra product, stroke partner, which would also be a product from Cisco or whoever. That's going to give you that extra functionality, but notice it's all built into Hyper-V. So even if you're looking at that free HyperV server for a small number of hosts for a small infrastructure, you can still deliver some of the advanced protection and security capabilities to help protect your key workloads. And that's important. We want to ensure that the platform has got all of the security features in the box. Right. So, but it isn't just about security. We need to make sure that things zip along fast, they're performant, we're getting the best out of what you've invested in. It would be great for us to say, okay, we can provide the most secure platform from a Hyper-V perspective, and your virtual machines will be isolated and secure, but they'll run incredibly slow. That's not good. The network vendors we're working with are building stuff, features, capabilities, enhancements. They're innovating in the NIC, in the physical NIC, that we're then presenting through to VMs. Why can't we take advantage of some of these innovations inside the NICs to drive higher performance in virtual machines? And that's where features like Dynamic VM Queue comes in, where we're effectively handling the processing of traffic within the virtual environment, offloading some to CPU optimally across cores, across the network adapters as well, and managing that whole process to optimize performance in the best way. And that's important because hardware that's got this is very common now, not just in super high-end NICs that cost an arm and a leg compared to the standard ones you get when you're speccing up servers. They're in commonplace. They're almost like baseline standard features now. And there are more advanced features as we go forward. IP task offload is a good example. IPsec, we use it extensively in Microsoft. Great way of securing access to information, data, as a user. If I gave you my laptop, you wouldn't necessarily be able to access all the data that I'm not allowed to access because of things like IPsec. So we're allowed to secure the network. But if you've got that within a virtual environment, think about a host running not 1,024 VMs, although we do support that, as we talked about earlier. But imagine a host running 20 servers. All of those 20 servers using IPsec. And each one of those 20 servers IPsec traffic needs to be encrypted and decrypted, which is a process that involves CPU and memory cycles. It involves resource of some shape or form.
And that could take away from your virtual machines
Yeah,
themselves.
if you imagine 20 VMs doing that, that's 20 times encryption, decryption, that processing of that traffic, all on that one host, which could really affect performance. However, IP task offload that now exists in some of the network adapters that are in the servers, we can offload it as the name suggests. So instead of processing it within the VM and ultimately burdening the host, we can offload it to the network adapter, which has dedicated resource assigned to handling that. So it's cool, and that's something we've got an advantage over VMware on. So it's really useful. But the big one, and I think this is going to become more and more prevalent as we go forward, and it's another example of where we're trying to help customers and partners take advantage of existing investments they've made in hardware. So if you've got network adapters within your servers that are SRIOV, single root I/O virtualization, SRIOV sounds a bit cooler and a bit quicker to say, SRIOV capable network adapter, we can do some cool stuff that presents a virtual representation of that physical NIC through to a VM. Now, before I go into the detail of what it looks like and how it's configured, I want to show you a bit of just how we enable that from a Hyper-V perspective. So let me pop over to my virtual machine, my hosts.
And just to jump in quickly while Matt switches here, essentially our goals are to reduce the CPU overhead and to reduce latency by basically, skipping this virtual switch. So, a similar thing that we had with storage was essentially being able to skip translation through the storage layer. This gives us somewhat of an ability to skip translation through the networking layer. So you have faster input directly between your virtual machines and your NICs without kind of an additional layer of virtualized translation.
Yeah, kind of like virtual fiber channel, which we saw earlier, a virtual representation of that physical HBA that's being presented through to the VM for enhanced performance and more native access.
Now, I know the first question I'm going to get, can we still do a live migration while we're using SRIOV?
Hold your horses.
Okay, jumping ahead here.
Yeah, you're just getting too advanced. We need to start with the basics, calm down. So I'm looking at Hyper-V, my Hyper-V infrastructure again, which we're all familiar with now. We've seen it about 10 times already. So here's my Hyper-V 5. Now, I've got to be honest, my infrastructure, my NICs don't support SRIOV. Okay, so I'm in that unfortunate position. Work with your OEM, work with your partner, work with your vendors to understand whether your NICs or your future investments do have the SRIOV capability. It's not just a NIC thing, but also a BIOS capability as well. It's something that needs to be enabled from a host perspective in multiple places. But once it is enabled, I can go into my virtual switch manager for my Hyper-V host. So I'm looking at the host. I've created a virtual switch already. It's what my VMs are using to communicate. And you'll see that I've got this option here, and it's grayed out now because I've already created and assigned, and it's not available on this particular host. So when I create a virtual switch, as we talked about earlier, I bind it to a physical network adapter. And when I do that, I choose my network adapter I want to bind it to, of which I've got quite a few in that host. And these probably support DCB as well, like we talked about before, because it's a converged network adapter, off on a tangent. But notice I've got this option here, enable single root I/O virtualization. Simple as that. Tick. OK, I can only configure it when the virtual switch is created. That's why it's grayed out. But if I was creating the virtual switch at this time, I would be able to enable it. But that doesn't do anything else at this point. All it does is kind of say, you know what, we'll turn on the capability. Like virtual fiber channel, when we created the vSAN before, if I didn't create any VMs with virtual fiber channel adapters, it doesn't change anything. I've just turned on the underlying capability. Same kind of thing here. Enable SRIOV, cancel out, go to a particular VM, into the settings, go to network adapter, hardware acceleration, enable SRIOV. Now, even if I enable this, I'm just going to get lots of events in the event log saying, your host doesn't support SRIOV, this isn't going to make a difference to your NIC, it's not going to change anything. So it's something to be aware of. What would happen inside the VM? What would happen when I enable this? Well, to do that, we need to go back to the slides to explain it a little bit more detail. But it was also a convenient demo because it enabled me to show you where VMQ is enabled, or dynamic VMQ, and IPsec task offload. So there was, again, method to the madness of why I brought you here. So let me pop out of there and let me go back, to the slides, because I want to talk about SRIOV in a bit more detail. As Simon said, it's aiming to reduce latency of the network path. So you think about what a regular virtual machine with a regular synthetic virtual NIC would have to go through. It goes through the HyperV switch in the parent partition, so the HyperV host OS, if you will, down to the physical NIC. So there's an extra bit of routing, filtering, transfer of traffic that involves a little bit of processing power from the host to manage that. But it's a very low overhead, it's high performance still. However, with an SRIOV physical NIC, the whole concept of SRIOV is you've got a physical NIC that you can touch, you can pick it up, it's a PCI card typically, or PCI Express or whatever. It's a physical NIC you can plug a cable into. But that physical NIC almost has its own little virtualization layer within it. So the physical function, the physical NIC, also has a number of virtual functions. So it's almost like a VNIC in itself. So an SRIOV physical NIC can have multiple virtual NICs. And that virtual function or virtual NIC, we pop into the virtual machine. So you can see how the path has changed now. The virtual NIC that's now inside the virtual machine is going directly to the physical NIC. So enhancing that performance. It does mean that we can't use some of the HyperV switch extensions that we talked about earlier because we're effectively bypassing the HyperV switch, but that's a choice you make. That's a choice you make, and you can certainly combine and configure this in different ways. So you mentioned the question live migration. This is where the magic comes in. So we enable it in the software stack, we enable it in the VM, and what we're effectively doing is inside the VM we're creating a team. A magic team that enables us to say, okay, now that we've got a NIC, I'm using quote-unquote NIC inside the VM, because all we're really going to see is a NIC, but it's effectively a kind of automatic team that we've created. All of the traffic, and the reason we've added SRIOV in the first place to this VM is for performance. So all of the traffic that we want to optimize for performance is going through that virtual function. So it's going through the SRIOV capable bit. The software path that was initially there is not used. Okay, but we've got the team for one process and one process only. Because when we want to live migrate the VM, we've got another host over there on the right-hand side. We break the team. So there's no interruption to the traffic at this point. It's all live. It's all optimized. We remove the virtual function. It obviously isn't as slow as this in real life. I'm just, explaining it step by step. There's not a break of a couple of seconds before each one. We migrate the VM, and we'll learn more about live migration later in the session. And here's where the magic really starts to come in as well. If we've live migrated that VM to a host that doesn't have SRIOV, the process will finish there. And the network traffic will carry on over the software NIC, the regular synthetic NIC. However, if we do have SRIOV on the target site, which I imagine if you're clustering and all your hosts are the same in that cluster, you're probably going to have them, but it's not always the case. Then we reapply the virtual function, team them up again, and stuff carries on. Magic. Yeah, that's cool, and that's awesome, and that's what we're doing there is ensuring that on the one hand we give performance with SRIOV, but on the other hand, we give agility. We don't say it's one or the other. Oh, you want live migration? Okay, turn off SRIOV. It's not like that. With HyperV, you can do both. So as I said, the VM has connectivity even if the target system doesn't have SRIOV, or the physical NIC isn't present that's got IOV, or if it's a different NIC vendor, different NIC firmware, we're not losing connectivity. We're not going to just live migrate and fingers crossed hope for the best. All of this stuff has been accounted for because it's what customers told us they wanted to do, and we've responded to that feedback. But just wrapping up the security standpoint, I'm sure you use Bitlocker on your laptop as a good Microsoft corporate citizen.
Definitely. Who doesn't, right? You kind of get forced as soon as you log in. And,
get forced.
Get forced. Not much choice there.
Yeah. So I'd like to do BitLocker. It ensures that if I leave my laptop behind in an airport or a taxi or whatever, my data at least is secure, but I'll be gutted because it's a Lenovo Carbon Touch and I've only just got it. So.
But what about data for our security for our physical data centers?
Exactly,
right?
Yeah, exactly.
It doesn't happen that often, but every now and then I hear these horror stories of basically armed robbers breaking into data centers, stealing racks of servers that have millions of credit cards, personal information, social security numbers. So having this physical security in the data center is becoming more and more important because this data has value. So you want to make sure that you're protecting the physical data as well from physical attack, not just from someone coming in over the network and hacking you.
Yeah, I think breaking into a big data center, if it's got all of the physical security, not physical security in this perspective, but physical people, security, swipe cards, all that kind of stuff is tricky. I'm also thinking about this from a server in a retail store. In a back room where I can come in, I can show my badge that I've just made in a popular graphics package like Paint, just knocked up a quick badge. I show it to the front desk and say, I've come to fix the server, I believe there's an issue. All right, okay, yeah, back into the storeroom or the cupboard I go. Oh, I need to take it away for analysis, out the door, it's gone. So I've lost the server, I've lost the data, the VMs on there, they may have, and obviously it's still a task to get to that data, passwords and so on, but if they've got it, you're in trouble, potentially. So in those environments, and not just security, but compliance. What if I've got a compliance requirement from a governing body or some kind of requirement that says, you know what, all your data has to be encrypted? How does that work in a virtual environment? Do I encrypt inside the VM and use valuable resources and pay additional software costs, or do I do something on the physical layer to ensure that the virtual disks are encrypted as part of that? And that's where Bitlocker comes in. So many people associate Bitlocker with laptops and desktops, TPM chips, that kind of stuff. So if you lose your laptop in an airport, you're covered. But Bitlocker is also in the server. It's been in the server for a while. There's a minimal performance hit by enabling it, but it enables you to encrypt local disk. And now in 2012, clustered storage that's presented as LUNs to individual servers. So if you've got two hosts in your cupboard or your data center, whatever it may be, and you've got a SAN in your cupboard as well, maybe, you never know, and it's presenting LUNs through to the hosts, you can BitLocker those LUNs. So local storage, C drive, D drive, whatever, SAN storage that's presented as regular LUNs, or cluster shared volumes, which we use predominantly for virtual machines. So all three of those repositories can now be virtualized. BitLockered from a virtual machine perspective, so we can encrypt that data. So if somebody did run off with the server, you're a lot more secure, that data is secure, and yeah, you've lost the server, but you've protected that data, which is arguably more important.
Great.
So yeah, that's a bit about BitLocker. It's a unique capability within Hyper-V and within Windows Server in general, and it provides certain organizations with a key capability they're looking for without having to kind of introduce third-party technologies to do that. When we look at the comparison with VMware directly across what we've talked about so far in this section, VMQ, it's important to know there's two flavors of VMQ. There's regular VMQ and there's dynamic. With the dynamic, it's more optimized balancing, processing of traffic across cores and CPUs in the system. So it's a little bit performance enhanced versus regular VMQ. Hyper-V supports both. VMware, in the form of NetQ, which is their version of it, is VMQ, regular VMQ. VMware has no support for the IPsec task offload, so if you're using that virtualized in a VMware environment, you might see that actually you could achieve higher performance in a Hyper-V environment. But here's the killer for me, the SRIOV with live migration. So I spent a little bit of time elaborating on why that's important. Performance on one hand and agility. With VMware, you do make that choice. SRIOV, you turn it on, that VM is locked to that host. And SRIOV is almost an evolution, although it's not a replacement, because you can still turn on both in VMware, although you probably wouldn't turn on both simultaneously, of a feature known as Direct Path I/O, which isn't specific to network adapters, but can be used. And Direct Path I/O in VMware effectively provides VMs with direct access to hardware devices, network cards, other PCI devices, and there's a list, I'm sure, on VMware's website of what kind of devices you can pass through. But there's a lot of caveats around Direct Path I/O specifically, memory overcommit, no vMotion, that host is locked, no fault tolerance, network I/O controls, snapshots, the endpoint security API, which we'll discuss later. So a lot of these things you have to turn off. SRIOV isn't quite as restrictive, but vMotion, HA, and fault tolerance for me are pretty big deals. And Hyper-V, we thought about that, and we've delivered that support with SRIOV in 2012. And also VMware don't have that support for the encryption. You would be looking at third parties. You might say, well, you know what, encryption isn't important to me. But if the scenarios that Simon discussed happens to you, then you'll think, wow, I wish I had have encrypted. But there you go. Also with VMware, it's important to note that SRIOV does require that distributed switch, that distributed vSwitch in the higher end edition Enterprise Plus. With Microsoft, it's in every edition. It's in the free HyperV Server. It's in all editions of Windows Server Hyper-V. So it's all there. A lot of flexibility, a lot of security. We've thought about this thoroughly, and extensibility with our partners, as we've discussed as well. And that brings us on to flexibility. How can we provide the most flexible infrastructure for virtualizing your workloads? Now, one of the key areas of flexibility is how we shift stuff around. VMware have had a feature in the platform for 3.5, perhaps I think 3, 2, it might have been 2.5, a long time, vMotion. And it's evolved and it's improved. Multi-NIC vMotion was introduced just recently. The whole process has been streamlined. It's an ability to move virtual machines between physical hosts. And I bet if you asked any VMware admin, what is your most used feature in vSphere, it's probably going to be that. I think it's what feature could you not do without, and it's probably going to be vMotion. Fair enough. And this was introduced from a Hyper-V perspective in Windows Server 2008 R2. How have things evolved? How have things changed? What were the feedback based on 2008 R2 and the capabilities that were in there for live migration? Well, firstly, we had a 16-node cluster in Hyper-V in 2008 R2. 16 physical nodes, shared storage. Live migration required the shared storage. Okay, and we'll elaborate more on this in a bit later. But one of the key things about live migration in that 16-node cluster was I could only migrate one VM at a time between two nodes. So 16 hosts, one VM at a time between two hosts. That means a maximum of 8 simultaneous migrations that would be between two unique hosts. That perhaps wasn't flexible enough for some organizations. And whilst you could serialize the live migration using System Center, so we'll migrate one VM and then another, then another, then another, we felt we could optimize more and provide more flexibility. So I want to show you how things have evolved in 2012 by going into a quick demonstration. So in this environment, I'm going to close HyperV Manager. I'm going to go to Cluster Manager. Remember, this isn't using System Center. We'll show and talk about System Center later on. What have I got here? Well, on this cluster, and Simon's going to show you relatively shortly in the next module how we got to this point, how we built this cluster, and we'll compare and contrast with VMware HA. But in this point, we've got a cluster. It's 3 nodes, as we said before. All 3 are running HyperV Server. And we've got this concept of roles. And to cut a long story short, and again, we'll elaborate later, a role could be a workload running on the cluster, a virtual machine, a file server, a DHCP service. And we'll touch on those later on. But I'm focusing on VMs at this point. And you'll see here, I've got a number of VMs all on node number 2. Owner node is current node, if you will, at this point. We'll select them all. We'll right-click. We'll go move. And I can still do good old quick migration, which was introduced in 2008, which moved the VM, but paused it when it moved and flicked over from the second node, which wasn't necessarily ideal for continuity, but it enabled people to move stuff around, if that's what they were looking to do. But I've got live migration here. And new in 2012, not only have I been able to select multiple VMs, I've also got this best possible node or select node. So a little bit of guidance around, okay, we think you should move all of these to some to node 3, some to node 4, or we think you should move them to all one node.
Now, a lot of people ask, what exactly does best possible node mean? Well, as we looked at System Center Virtual Machine Manager in its past release, one of the most popular features was this ability to essentially rank what is most important to you when you pick a host for placement. And we had options such as using memory, CPU, network I/O, disk I/O, and very broadly, number one thing was memory. Memory was the biggest constraint which people had running on their hosts. So this was a popular feature because it freed up admins' time when they needed to move a couple of virtual machines around. They didn't have to think which host has the most memory. Let me go launch perfmon, let me look at traces. No. It was basically gave you an easy way to select this host has the most free memory, we'll automatically move there. So we bought this feature inside Windows Server 2012, failover clustering, and now when you select the best available node, it's automatically going to move the VM to the node with the most free memory. So as an admin, if you're migrating 10 VMs at the same time, or even if you have a massive cluster and you're migrating hundreds of VMs at the same time, it simplifies the amount of brain power, amount of processing you need to do, because we will just automatically place it on the host with the most free memory.
Yep. So I'm going to carry on with the demo. I'm going to go with the select node option, and I'm going to click. So when we get back on with the demo, here we go, select node. It's going to present me with a very jazzy interface, 2, 3, or 4. I can choose the host that I'm effectively want to migrate to. I'll go 4, okay, in this case. and go OK. And you'll see, there we go, live migrating 333%. If I'm using quality of service on any of these host NICs, then you're going to see them move at different speeds, but they're all going pretty fast. And I've chosen 4 there, and I can actually configure a higher number of simultaneous migrations, much greater than that. But largely, the number you would choose, your bandwidth, your pipe between these hosts is only so big.
Right.
If you've got a gigabit pipe and you try and move 10 busy VMs, those 10 VMs are going to be migrating for longer than if you moved 4 at once and then the next 4. So it's just something to be aware of. And live migration has a minimal performance hit on the virtual machine, but if the rate of change inside the VM, if the churn of memory inside the VM is faster than the rate of migration and transferring those dirty pages, and Simon will explain this shortly anyway, then we're going to slow the VM down slightly to make sure that process finishes. But we're never going to leave you in a state where the VM isn't running somewhere. And that's important. We're not going to live migrate into a black hole. So that's very smooth. So what we're going to do, a tip of the day as well, because in 2008 R2, there was a tick box that was kind of hidden in the depths of the interfaces that allowed you to select which network you'd use for live migration. In vSphere, you'd go into vCenter, you'd select your network adapter, use for vMotion, or this particular vSwitch is used for vMotion, put it on a different subnet, whatever you may, simple. Here, to designate a particular network for live migration, of which I've got a few here, you don't just call it live migration and that's it, game over. You right-click, and now it's just here. How easy. Happy days. I lost many a hair over trying to find that particular interface on a tab here, there, and everywhere within Cluster Manager. So live migration, tick box. If you've got multiple, you can order them as well. I'm just going to use that particular one and go cancel. So that's the network we use. And we can monitor that. We can monitor the traffic across that. And what you see is we can utilize 100% of that available network for live migration. So it's very efficient and very streamlined, that whole process. But what you saw, just for argument's sake, we'll select them all. We'll move. We'll live migrate. Select node again, we'll move them back to node 2, and we'll go OK. Notice node 4 as well, demo 6. Demo 6 was the one we had the virtual fiber channel on before. Still attached, it's virtual fiber channel, still attached to that VM, so no disruption in access to that particular storage interface. And I'll just prove it. So in fact, let me just select one, settings, and there we are, fiber channel, fiber channel. So we've moved it across, even though it's got the virtual fiber channel adapter. So I'm going to go back to the slides, and we're going to hand over to Simon, because Simon's going to explain and go into the depths and nitty-gritty around how live migration works and blow your mind with it. So.
Well, I'm not sure anyone's head's going to explode, but I'll certainly cover the basics here. Now, essentially with live migration, the key thing to remember is that both servers need to be running at the same time, because we're transferring memory from one to another. So I often get asked, if one of my servers crashes, can I still live migrate the VMs off it? No. What's going to happen with a server crash is the VMs will go offline, the other nodes in the cluster will detect that a failure has happened, and then they will restart the VMs on another node. So again, important point, you need both servers to be active as part of this live migration process. So essentially what we do when we go and initiate the live migration, we start to copy all of the in-state memory from our first host over to our second host. Now, just to kind of clarify with some virtualization concepts, remember we have shared storage. That has all of the fixed data which is written to the disk, our VHD, VHDX files. But then we have this running in-state memory that's active on the host. So what's on the disk is going to stay. What's running in the actual host, that memory, that's what we're going to be moving around. So when we go and start this live migration, we'll take this big chunk of memory and we'll start copying it over the live migration network. And basically, we're going to make a clone of this in-state memory on our second host. Now, while this is happening, the VM's running, right? It's active, our users are connecting to it, there's processing that's going on, and that in-state memory is actually changing. Now, what we do, as soon as we start that first live migration, we keep track of the dirty pages, basically the components which are changing in our memory. We then, after our first migration is complete, copy those bits that have changed and perform a second migration. While that second one's happening, pages are getting dirted, things are changing. Now, that second migration will take much shorter, so there'll be fewer changes. We do a third, keep track of changes, a fourth, a fifth, until we essentially have both of our VMs running at the same time. So when a change happens here, we see it here. Now at this point, we basically have identical VMs running on different hosts. So what we now need to do is reconnect our clients or our applications from our first host over to the instance on the second host. And we do this simply by sending an ARP, an address routing protocol, to our actual switch or our hub that's connected to our first host, and tell it to update the routing tables and start sending customers over to our second host. So from the user's perspective, nothing happens, right? They're accessing memory in this location, they suddenly get directed to a clone of that same memory in a different location, they continue to work on the same application, same product. Now, once that process is being completed and we've redirected our clients to the second host, we then do some cleanup actions where we will delete the VM on the original host, free up the memory, free up the resources so that it can be reallocated.
Yeah, and that's the key, is that Simon explained that in a way that made it sound like it takes a really long time. You know, we're running 2 VMs simultaneously. It's fractions of a second. It's bang.
It is.
Everything, all the pages have been copied, we've captured, we send it across, and it's done. So it's not kind of, oh, 2 VMs, I can see both, and then one disappears. It's literally whew, like that, you know, with that sound effect. But we also talked about, that's optional, we also talked about shared storage as a requirement. Now, my question to you then is, does it have to be fiber where we're storing these disks? Does it have to be iSCSI? Or what options do we have for these centralized virtual disks?
Great question. Well, we could use any type of shared storage which is supported by a cluster. So now this is just for a live migration within a cluster. A little later, we're going to talk about live migrating beyond clusters, but just within the scope of a single cluster. Any type of shared storage which is supported by the cluster. So this could be fiber channel, serial attached SCSI, iSCSI, fiber channel over Ethernet, or SMB 3.0, Server Message Block Protocol. So a lot of options you have, and very shortly we're going to be talking about other types of live migration, and with that you actually have more options, even using direct attached storage or a variety of other protocols.
Great, and that leads us perfectly onto the next slide, which focuses and just explains and shows in a diagram format that SMB storage. So we've got a simple SMB network share that's exposed to 2 hosts. It's / Simon share. The VM is currently running in memory, as Simon explained, on host number 1. We've got a connection between the 2, and we start sending the config data, i.e. the VM, what it does, what its characteristics are, and then we transfer the memory pages across. Modification, as Simon said, and then the VM and storage handle is moved, and we're happy. Everything's great, and we've moved it across. But what about some of these others? What about some of these other examples? Live storage migration. The VMware guys on the line will be thinking, okay, storage vMotion. That's how you want to equate that. Moving the running disk or the disk of a running VM from A to B with no downtime. So let me show you very quickly what that looks like. Back in our clustered environment, here we are. I'll choose demo 5. I'll right click, move. Notice I've got this other option, virtual machine storage. I can literally say, okay, what makes up this VM? There's a VHDX file, there's some snapshots, there's some paging information, and the config file itself. And here's my current volumes that are exposed to this cluster that I can choose from. It's currently in volume 3. I'm going to drag to volume 1. So destination, volume 1, and we'll go. And so that's moving the storage across. And that's going to take a little bit of time because it's going to move all of the gigabytes of data that's associated with this particular VM. It's not moving the VM itself. That VM is going to stay put on node number 2. It's just moving the disks. And to explain that in a little bit more slide detail, the reads and writes are going to that source VHD or VHDX file, and that could be on SAN storage. It could be local storage. You could be moving from 2 DAS disks in the same host. We're leaving the VM where it is. Disk contents are copied to the new VHD. So we've said, yep, start the migration, and we're copying everything across. So we're copying everything to a new VHD effectively. But it's going to get to the stage where we finish that copy and we start mirroring out the writes. So we're writing to 2 locations. We're writing to the source VHD and our new target VHD, whilst also keeping things up to date and replicated. And then finally, once everything's in sync, we just change the reads and writes to go to the new VHD. And that's similar to how VMware do it. It's very similar, very simple processor, but what we're achieving there is a lot of flexibility.
Now, in that little demo you showed, it looked like you migrated between two LUNs which were in the same array. Can you actually do a live storage migration from different arrays, different LUNs?
Well, yeah, as long as the host can see. If they appear in that little list there, they were 3 different LUNs, but if they appeared in that little list I could choose from, yeah, absolutely. If you want to go beyond that, so maybe you want to migrate outside of a cluster onto completely different storage as well, so maybe you wanted to migrate between 2 standalone hosts with no shared storage, then that's where it brings us nicely onto our shared nothing live migration. And this was introduced in HyperV first in the industry. So this was before 5.1, vSphere 5 was still shipping at this time, and shared nothing live migration enables an organization to shift a VM, its state, like you explained before, so like demo 1, we showed where we moved the state, the runningness of the VM, and its disk at the same time. So you think you're taking everything that associates about that VM, its config file, its paging file, everything that is the VM, and you're picking it up from cluster or standalone hosts, and you're dropping it anywhere else that's got a network connection to that server that's running HyperV 2012. So that is flexible, and we'll show what that looks like very briefly here. So I'm going to go over to my HyperV Manager interface, actually, and I'm going to pick up demo 7, and go to move. I'm going to go next. What do I want to do? Move the VM or move the storage? I'm just going to move the whole VM and optionally its storage. I'll go, yeah, next. When we're going to move it to, we'll move it to node 3. Oops. We'll go next. Choose the move options. Do you want to move all of the VM stuff to one place? C drive / folder 1. Do I want to move stuff separately? Move the config file to there, move the disk to there, move something else to another place. Or just the VM state. Now the VM would need to be on shared storage for that. I'll move it to a single location. We'll go next. Browse on that particular target host. Go into the VMs folders, fine. And we'll go next, and we'll go finish.
So what you're showing us now here is we're really extending the concept of live migration beyond nodes in a cluster.
Correct.
Now we already said that, hey, we can have 64 node clusters, but essentially now that we can live migrate beyond a single cluster, essentially we can expand and have live migration anywhere in our data center.
Exactly, and it opens up the possibility for automated load balancing beyond clusters. So if your cluster is overcommitted, or you've moved and balanced loads within a cluster in such a way, and we'll talk about System Center later on, and you think, well, we could in the future see where we're load balancing outside of clusters, moving things around, providing the network topology allows it. We don't want to move to somewhere where this VM is now completely isolated, but it runs great. So it opens up all sorts of new scenarios.
So a lot of people then ask me, okay, so you can live migrate beyond a cluster. Why would I still need to use clustering? So again, an important thing to remember with live migration is that both nodes need to be online the whole time to participate in a live migration. So it protects you for planned maintenance, allows you to move things around. But what you still need a cluster for is that unplanned downtime. Now remember, what happens with a cluster is nodes are constantly detecting the health of each other. They have a clear list of what every other node in the cluster is running. So when a single host crashes, brings down the VMs, those other nodes can detect it, restart the VM somewhere else. So clustering is still needed, still used for this unplanned downtime for automatic recovery. Live migration is going to be used for planned downtime where both nodes can be active participants.
So I wanted to wrap up the session with talking about how we can enhance flexibility from a networking perspective. We talked about the Extensible Switch and the cool stuff that enables from a security and an extensibility perspective. But what about organizations who are looking for that simplicity, that next generation of software-defined networking capabilities within their data center? And that's where network virtualization really starts to provide incredible value for organizations. It can provide isolation, so we can isolate VMs and workloads without needing to use VLANs or PVLANs. So that's benefit number 1. So we can isolate traffic from different business units or customers without VLANs. We can move stuff around the infrastructure whilst preserving network assignments. What does that mean? Well, if I've got 2 clusters, as Simon said, but they've got different physical fabrics, so one physical network is on the 192 network, one physical network is on 10.10, and your VMs are all 192 that are in this first infrastructure, we can move them across to be running on a 10.10 fabric, and yet the VMs themselves can still retain their 192 IP addresses. And we'll explain what this looks like in a bit more detail shortly. It means if you're a company who regularly acquires other companies and you want to onboard them into your infrastructure, into your data center, but retain their IP assignments and addresses, then you can do that. So realistically, you could onboard 2 very popular cola manufacturers into your infrastructure, host their VMs on the same physical fabric, isolate them, and even if they've got the same IP addresses within their individual networks, the network virtualization isolates both of those 2. So they could have overlapping IP addresses, but they would never conflict. And let's explore that in a bit more detail. But firstly, let's have a look at why this has become important. Think about VLANs, switches you mentioned before, 65,000 addresses, which was slightly ambitious. So 4,095 is the most number of VLANs for a switch. However, certain switches don't support that many, maybe 1,000. And we've seen customers run in who've deployed the best-in-class switches but only support 1,000 VLANs, and they're already starting to get close to that number. So what's their next step? The configuration challenge ahead of them is huge, and I don't envy them. But think about this scenario here where we've got different VLAN tags. The VMs in the network that are virtualized on the host are each connected to different VLAN tags, and we've got some top-of-rack switches, and then we've got some aggregation switches that are connecting those top-of-rack switches. If we want to introduce a VM here on the second set of hosts on the left-hand side, that's a red VLAN. So we need to make some adjustments on the host and on the switches to make sure it can communicate with the other red VM. What happens if we introduce a red VM on the other side, the other top-of-rack location? Well, we need to make some changes here, 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 and here, and here, and there. That's a lot of changes. And in many cases, network reconfiguration, VLAN reconfiguration, can result in unpredicted outages, where a misconfiguration has been made and something has gone wrong. And sometimes that topology and where we've got VLANs ultimately determine where VMs and services have to run. We want to provide more flexibility than that. And with network virtualization, we want to do the same kind of thing to the network that we did to the VMs. We took a physical server, we abstracted, and we virtualized and created VMs. We want to take the physical network fabric and the subnets and virtualize those subnets and provide that isolation boundary for blue and red in this case, so they can both run on that same fabric, that shared simplified fabric, and each virtual network has this illusion that it's running on a physical server. So that's really powerful. That's helping us achieve more flexibility when placing workloads, but everything is still isolated and has this illusion that it's got the complete infrastructure to itself. Which, as a service provider, as a large enterprise, somebody embarking on that next-gen networking solution, it's there, it's in the box. So there's a couple of terms that we need to be aware of. Firstly, this term of customer addresses. These are what the VMs see inside the virtual machines. So Blue Corporation has a couple of VMs that are 10.0.0.5 and 7. Red, coincidentally, also has those same IP addresses. Now we want to host those network and those infrastructures on our main fabric. We want to move them across to our shared infrastructure, and you'll see that Blue 1 and Blue 2, we're going to coincidentally sit them alongside Red 1 and Red 2 on those different hosts. So you think if they weren't using VLANs, there would be a conflict. If they were using VLANs, we'd provide that isolation, but VLANs are a little bit more restricted than what we're providing in network virtualization. So in this customer address space, the CA space, those are what the VMs have. But the provider address space, you've got CA for what the guest OS sees as its address, and PA, what the hosts have as an address. And HyperV Network Virtualization is effectively providing and maintaining a mapping between the PA and the CA. So blue in this case, CAs are 10.0.0.5, and it's mapping currently to host 4.11. 10.0.0.7 is mapping to 192.168.4.22. So we're maintaining that mapping at the moment. If we had lots of blue VMs on host 1, they would all have that same PA address of 4.11. And the same kind of thing for red. We're maintaining a 10.0.0.5 for the CA on a 4.11 for the provider address for red. And System Center Virtual Machine Manager is maintaining all of that. And it deploys to each of the hosts in the environment the relevant pieces of that virtualization network table that that host needs to know about. So it doesn't just send a copy of everything down to every host, it just provides the key bits that it needs to know. So to understand this in a bit more detail, a customer network, one or more virtual subnets forming an isolation boundary. So here we've got blue R&D net that has blue subnet 1, subnet 2, subnet 3, blue sales net, subnet 5, subnet 4, and they're broadcast boundaries in the similar way they would be in the physical infrastructure. And the red has obviously got a red HR net, which is the customer network, and it's got a couple of virtual subnets within there. But in terms of what we're using something called NVGRE, which is a standard. It provides that scalability by sharing that provider address among VMs. So the VM doesn't really, as a guest OS, have any knowledge about this provider address. It doesn't know about this physical address it thinks it's got an entire infrastructure to itself. It doesn't know about the 192 addresses in this case. But we can also move virtual machines across subnets. But how are we identifying the differences? How are we identifying and isolating these workloads? Well, think about it. We're able to move virtual machines between these different subnets by adding extra information to the packet. Okay, and we'll explore that packet flow shortly. So if 10.0.0.5 wanted to communicate with 10.0.0.7, even though it's existing on a different host in a different subnet, how would it do it? How is that traffic going to get there? Well, what we're doing is maintaining a lot of the information about the packets and also the extra information we bolt on the end of the packets or on the front of the packets to ensure that traffic goes across the regular network. And all of this is maintained in the Hyper-V hosts. So System Center maintains, as we said before, the policy tables, which for VM1, we know its MAC address, we know its customer address inside the VM, we know the provider address of which host it's on, and we pass that down to the host. Some stuff takes place in the Hyper-V switch, and they can operate in that customer address space. We can still use switch extensions with network virtualization, but NV is operating at a slightly lower point in the stack. So we're able to transmit traffic through that. And I want to show, just briefly, because we're conscious of the time, what the packet flow would look like. So here we've got blue on the left, wanting to send information, a packet, to blue on the right. And bear in mind that these physical hosts are on the same subnet, but they're on completely different hosts in this case. So firstly, blue is going to say, where is 10.0.7? It's going to send out a normal ARP request for that. And that Hyper-V switch broadcasts the ARP to all the VMs on that particular virtual subnet ID. So that's something that uniquely identifies Blue's virtual subnet. And it also broadcasts it to the network virtualization filter. It does not broadcast that ARP request to beyond that host. So it says, okay, for this VSID, I want to find 10.0.7. The network virtualization filter, so this section here, responds to say, okay, it's over here. Because it's got that information because VMM has provided it in the network policy table. So it's provided that back. It's not broadcast on the network. So the network virtualization filter has said, here's the ARP for 10.0.0.7 on this particular VSID 5001 and the MAC address of the VM. So what happens next? Well, that gets back up the chain. Yeah, it says, okay, use this MAC for 10.0.7. Blue 1 learns the MAC of Blue 2. Standard networking stuff at this point. Then what's sent? Okay, sent from Blue, because remember, it doesn't know network virtualization. The VM is completely transparent of all of this. So what's sent is a regular packet. Okay, I want to send information from the IP addresses from my Mac to your Mac. But in the Hyper-V switch, we attach the VSID that represents that virtual subnet ID. And that's all combined and aggregated in the network virtualization filter. And on the wire, NVGRE, that standard we're talking about, this is what the packet looks like. So the virtual stuff, so VM address to VM address, virtual MAC to virtual MAC, the subnet ID, then where it needs to traverse from a physical perspective, so from .11 over here to .22 over here, and then the physical MACs again. So we're effectively bolting something on the front of that that's encapsulating the virtual packet so it can go across a physical network. And once it gets to the other side, so receiving NVGRE across on the wire, that full packet gets received. Network virtualization filter strips off the relevant NVGRE bits that it doesn't need now, passes that up to the Hyper-V switch, and what's received by Blue is just the packet that was originally sent. So the best way to think about it is it's like putting something in an envelope and sending it. you've got your message. You've got your address back from somebody who's told you the address of Simon, so I know where to send it to, and I'm putting it in an envelope. The packet is going in an envelope, the MVGRE, and it's being shipped across the regular postal network until Simon receives it and he opens it and then he gets the packet. So it's that kind of approach. It's probably quite a useless analogy, really, but hopefully it helps to illustrate for those of you with efficient postal systems. Anyway, what that's highlighted, hopefully, is just how network virtualization works. And you could have a day on network virtualization in its own. It's complex, it's technical. If that's the first time you've seen it, you're probably scratching your head a little bit. So ask questions to our experts and look online. There's some great tech ed sessions you can also view on Channel 9 and MVA around how this stuff actually works. But to wrap up, live migration, it's in the box. We don't restrict you. You can migrate as many on gigabit and 10 gigabit as you want, but you'd want to assess your workloads and how that operates within the technical confines of your actual adapters. With the vSphere hypervisor, the free edition, there's no clustering, so there's no live migration. So you can't move anything, you're restricted to that host. With vSphere, Essentials Plus, Standard Edition, and so on, you do have some of the migration capabilities as well. Storage vMotion is in there for the VMware side, storage migration for Microsoft, and the shared nothing live migration was introduced in 5.1 as well. What's interesting to note is that whilst that storage shared nothing live migration in the VMware world, I think it's just still being termed vMotion. Some people call it enhanced vMotion. Some people just stick with regular vMotion. What's interesting about the storage migration is that's only restricted to some of the higher end edition SKUs, so Standard, Enterprise, Enterprise Plus, and not in, say, the Essentials Plus SKU for SMB. And yet I can still move the VM and storage, but I can't move the storage on its own, which is interesting, but there you go. HyperV is just offering that complete flexibility. And when we think about network virtualization, VXLAN is a feature of the vCloud Networking and Security product, so an extra product you would bolt onto vSphere. So if you wanted to use a network virtualization, slightly different, has a slightly different approach, but achieving ultimately the same goal of avoiding regular VLANs and the restrictions, I think both VXLAN and network virtualization for HyperV supports about 16 million isolations, if you will. So pretty scalable. It's only available in that higher edition. And my question to VMware admins and customers is, now they've acquired Nicira, what is the next step for those organizations? Do they go down VXLAN and deploy a software-defined network that way? And when Nicira comes in, network virtualization, again, slightly different, what do I do? That would be my question. With network virtualization with Hyper-V, that's how it is, and it's going to evolve and improve, but we've set down the standard of how we're going to deliver it. So you can be consistent and confident.
Well, with that, thank you, Matt. Our next module, we will be back for in approximately 10 minutes after this break. Please make sure that you click on our poll. We got some great information that we're collecting, so if you're in full screen mode, you can minimize and answer those questions. And when we come back, we're going to be talking about availability and resiliency. Thank you.